Second property, the reactivity of non-metals generally depend on its electronegativity. The larger is the electronegativity, larger is the reactivity. As the electronegativity of the elements in a subgroup decreases downwards, their reactivity also decreases in the same direction. For example, F sub 2 is more reactive than Cl sub 2 in group 7A. Similarly, O sub 2 is more reactive than S in group 6A. Exception: phosphorus is more reactive than nitrogen in group 5A. Hence, there is no rule for the reactivity of metals and non-metals in a periodic table. These are only guidelines. Second, metallic character increases from top to bottom in a group because the atomic size increases and ionization energy decreases. Example, metallic character increases as Li less than Na less than K less than Rb less than Cs. Similarly, C less than Si less than Ge less than Sn less than Pb. Here left side is non-metals and right side is metals. The metallic character changes in the reverse order. Third, the most electropositive elements are found in the lower left of the periodic table and the most non-metallic in the top right. Fourth, transition elements are metals. Next, density. Density of elements in a group generally increases because of larger increase in atomic mass than in their atomic volumes. Thus, the densities of alkali metals of group 1A are given below. Elements and density, their corresponding density. Li density 0.54, Na 0.97, K density 0.86, Rv density 1.52, Cs density 1.87. Similarly, next, elements and density. Be density 1.86, Mg density 1.74, Ca density 1.54, Sr density 2.6 and Ba density 3.74. Thus, K is exception in group 1A and Mg and Ca in group 2A, that is in second part. Now, natures of oxide. Generally, acidic nature of oxides of element increases in a period from left to right, but basic nature increases in a subgroup from top towards bottom because of increasing electropositive character of elements. Next, atomic volume. It is the volume in milliliter occupied in the solid state by 1 mole atom of the element. It first decreases and then increases as we go from left to right across any row of the periodic table. In a group, its value is found to increase with an increase in atomic number. Next, types of element on the basics of electronic configuration. There are 4 types of elements based on their complete and incomplete electronic cells. First type, inert gases or noble gases. Their outermost shell is complete with Ns sub 2 p sub 6 and thus have a stable configuration. They are inert gases and except helium all have 8 electrons in their outermost shell. Helium has 2 electrons. They thus have the configuration Ns sub 2 p sub 6 in outermost shell. Because of the stability of their electronic configuration, they do not enter into ordinary chemical reaction. They constitute the zero group on the periodic table. Second type, representative or normal elements. Representative or normal elements, all of their cells except the outermost are complete. The electronic configuration in the outer quantum levels of the atoms of these elements include Ns sup 1 except 1s sup 2 for He, 2 Ns sup 2 and p sup 6. They thus enter into chemical combination to acquire 8 electrons in the outermost orbit, or to acquire sp configuration by losing, gaining or sharing of electrons. For example, hydrogen, alkali metals 1a and alkyl earth 2a are s block. The normal elements while from 3a to 7a are p block elements because they have from 1 to 5 electrons in their outermost subshells.